components side of GitHub. They're a whole like little component library that you can use. And then the other part, the other one is more like accessibility tooling.
Mm-hmm.
So like making the tools that are used for like calculating the different accessibility grades and testing and things like that. It was actually kind of neat because for my code challenge, it was trying to build a tool, like just starting to build out a tool that would calculate color contrast based on like a given color. Which was kind of neat because like I actually didn't know how that was calculated. I've like seen the calculations out multiple times, but I just didn't really realize how it worked.
Right.
Are you determining the distance, so to speak, between two colors?
That's the luminosity like difference. Like
So just the value portion, the brightness portion?
yeah, you like compare the you calculate like you calculate luminosity like
I would guess the green has to be weighted a bit because it's so much stronger than the red and the blue.
well, it's just all based off of black and white.
Oh, okay.
Like how much they differ from like because like black's basically like the darkest a color can technically be, and then like white's the lightest a color could be, and so you're just kind of like looking at like how
Oh my goodness.
What?
Someone we haven't seen in a while.
Dang, we're gonna have to move again.
Yeah.
That took me forever to figure out where we got. Checking out never months.
What was the language you were doing the contrast stuff? Was it C#?
they had me doing it in for that one. Technically, it was JavaScript. But I was
JavaScript. Okay.
All right. I'll let Richard get settled, and then we'll get started here.
Who knows, maybe like if I actually get that position, I could get like the massive amount of stickers I see like the other people have when they go.
Mm-hmm.
Which is kind of neat. Like, so like one thing I made sure, of course, to ask them about was kind of like checking to see if they had any policies or anything that would impose any kind of like limitations in terms of like where I can speak or whatnot. Because I know like some places do. Some places you've got to like have your templates and what content you have reviewed. At least if you're taking like paid time off or unpaid, like regular time, not having to all day pay. And like from what I understand, at least for the most part, unless you're like going to speak like as a representative of GitHub and like on GitHub products, they typically wouldn't pay for anything. Which that seems to be unfortunately the case a lot of places, you know. But they will like, even regardless of whether you're acting as a representative of GitHub, like I straight up at the beginning of my talks always say, I'm not representing where I work. They said even if you're doing that, they'll still give you things like stickers and whatnot to take with you because it's still like, kind of like, you know, you're still technically kind of representing the company regardless.
So, I mean, quick funny story. I remember when I was working at HP, and I was getting people, from HP to be able to speak. And, I think it was DevUp. I think it was where we were going, and I, was trying to convince the company to pay for them to be able to go, right? So they pay their travel and such. And the senior executive vice president, whatever her title, I mean, really high up title. She agreed, but she's like, but I need to review the presentations. So it's funny because it, I right away was like, I'm okay. So there's four of us. I was like, I'm okay. The other one that I was working on, she was same level as I was. She was like, yeah, I'm okay. Because we both know this lady well. That we're like, yeah, we don't want her reviewing our slides. But then we had two other very young and ambitious folks who was like, yeah, let's go for it. Yeah, they embarrassed me. So I'll tell you who it was later. You might already know. At any rate, So welcome. Thanks for coming. We got two folks who we haven't seen in a while. That's awesome. So a couple quick announcements, if I can get on the right thing. Come on. There we go. All right. So as far as upcoming events, actually, I realized I forgot to put one on here. Last Saturday of April is Atlanta Code Conference. That's not too far away. They haven't published their schedule. I can tell you I'll be there. I'm going to be talking about messaging patterns. So that's always a good conference. First Friday in May, so Oaks Day, is Star Trek. That's always a fun event because it's at a movie theater, and at the end of the day, so this year we'll be watching, what is that movie? The new Marvels movie that's coming out in May. I forgot the name of it. Not Thunderbirds. Whatever it is.
Fantastic Four?
Hmm?
Is it Fantastic Four?
No.
Oh, did they actually make another Fantastic?
Yeah, so you are making another Fantastic Four, yeah. So that's early May.
Thunderbolts,
Yes.
May 21st.
Mhm. No, not
May
that.
2nd.
Yes. Since Deliver is, I gotta remember, August 2nd, I think it is. We've always done it the last Friday of July, and this year it's the first Friday of August. But it's always a good event right up in Cincinnati. And then Beer City Code is up in Grand Rapids. Grand Rapids, so a little bit more of a stretch as far as drive. That is in first half of August. And the one I forgot to put up here was DevUp, which will be also, it's actually the same time as Beer City. So definitely some good events coming up.
Are you going to MVP Summit next week?
I am.
I'm jealous that I can't be there, but at the same time,
The hard part about that is my wife has been in the Philippines the last 2 weeks. She gets home tomorrow night, and then I leave tomorrow night to head to Seattle. So upcoming meetups. Actually, June is now scheduled. I just didn't get a chance to update it today. So May, I'll get something worked out for May. I'm sorry, for April. For May, we're going to have a session about intelligent agents. So you'll hear the words like agentify and agentics and all these fancy little terms that Microsoft likes to use now. Actually, I just saw a demo of Copilot Studio yesterday, some stuff that's coming out. That's all I could say that what I saw about it was really, really cool. Some stuff they were doing with it. And then in June, I forgot the exact title, but basically it's a talk about security. And assigning, what's the right way to do security, and such. So, all right. And then, I don't know if I already lost my, this is going to be fun. I forgot my clicker at home. So, and then sure enough, afterwards, so for those who haven't been here for a while, we now go to Brick House. But definitely come join us. All right. So tonight's presentation. So the dark side of design patterns. So it's funny the way how I came up with this talk. I was actually at Beer City 2 years ago, and at night, maybe had a couple of adult beverages. So the mind was freely thinking, and a bunch of us talking. And I was like, I always love it when people say, "Oh, well, we'll use these design patterns," and then all of a sudden it really screws them up, right? And they're like, "Well, but I use the XYZ design pattern." I'm like, "Well, yeah, and that's exactly the kind of problems that we'll have with it." So that was kind of like the genesis of this talk. And again, all these design patterns I still use, right? I mean, it's not like these design patterns are bad. It's just you have to think about when you use them. So. All right. Everyone in this room knows who I am, but if you don't, there you go. So design patterns, and I got to admit, I did not rehearse this again, so I haven't given this talk in a couple months, so I got to remember it. But what are design patterns? What are we talking about? Well, the idea, one is code reusability, right? whole idea of a design pattern is it's a pattern of, so something we see happen often, generally in successful applications. And so, and we can reproduce it. And that's one of the things we get with here. It's, if you say, well, I'm using the singleton pattern, well, I can easily reproduce that again because it's got a reusable type code. Next is generally these promote scalability and maintainability. Because generally we don't write down the crappy design patterns, right? We generally write down the good ones, right? Generally the crappy ones are anti-patterns, right? Common vocabulary. Again, I say the singleton, probably everyone here knows what I'm talking about, right? The whole idea you can only have one object at one time, right? As an architect, part of my job is to be able to design these systems and then, talk with the developers. Hey, here's what you need to build. You need to use this pattern, that pattern, and so forth, or use this type of, idea. And again, when I say the singleton pattern, the developers know what I'm talking about. They are best practices. They also, a lot of times provide abstraction, and give you some more flexibility. And we'll see some of that in here, in some of the talks or ones we're talking about. Ease of maintenance, learning, and then, documentation, right? Again, I can easily write down the reason, a pattern, and I don't necessarily need to document everything that the system's doing, right? I can leave it at that. With that being said, the goal is also not to just use every design pattern possible to build your system. All right. So I laugh about this and I joke with them now. So Jasper, my final interview with him, I went into Jasper and they were doing a presentation, right? Because of course, interview should be a two-way interview, right? So they're doing a presentation of the system that we're actually finally deploying a couple weeks, and they went through the whole series of slides where they were talking about all the design patterns they were using for this one system. And I know they were trying to impress me. Like, oh, look, we're using all these things. And I'm like, yeah, but did you have a reason for using all those? Or was it just because we wanted to use those, right? That's great. But so, that's kind of part of the point of the talk tonight. So as far as, where they came to be, they've been around forever. Really, they're almost as old as software development. But the real popularity became with this book, normally referred to as the Gang of Four book, which is the four guys who wrote it. This came out in 94. I was way off my dates there. But anyway, it came out in 94. And the big thing is like I said, they didn't come up with any design patterns. They cataloged these design patterns. And this is the first time we really had a good catalog of them. And the more important part that they did was they categorized them, right? So they came up with 3 different categories. First being your creation pattern. So things like the interpreter, the observer, command, iterator. So things that create objects, right? So how do we successfully create objects over and over? The next group was the structurals. And here, here we're talking about the structure of an application, right? So the factory pattern, which I'll be talking about, the idea that you have something I can give it and it builds the object for me, right? It builds the structure of the thing. And the final group they came up with was the behavioral. So these behavior of how the application works, right? So like a facade is a perfect example, right? Because a facade, the idea is that it presents to the consumer of that application, usually another application, here's what it looks like, but behind the scenes, it's actually doing something completely different. But there's others that we should be thinking about, right? There's architectural patterns, right? So, earlier I was asked, so what am I working on? I said, well, I'm doing event-driven serverless microservices. Those are architectural patterns, right? They're not design patterns, and say they're defined a bigger area, right? So a lot of things you'll see here, like your model view controllers, right? Your event-driven architecture, your microservices, and so forth, right? And there's others, different types of design patterns, but the big thing is they're not all created equally. They all serve different purposes. Some are really small and meant to, they serve, smaller purposes, but they all don't solve all the problems. And the big thing we need to think about is, one, they should be applied judiciously. Again, I bring up that, when I have the second meeting with Jasper and they're showing off all these design patterns, right? And again, my first thought was, yeah, but did you actually use them, correctly, right? Was there a reason for using these? It turned out actually, for the most part, yeah. But you have to think about that. Are you actually using it for the software you're developing? And this is the hardest part for most developers, right? Because we're geeks. We love technology. We love new things, right? And how often is it you're looking for a solution or a problem to solve, right? I said, in May we're gonna have a presentation about Agenix, and such. And how often do you, when you hear those kind of things, you're like, oh wow, where can I use that to solve a problem? Not the, hey, I have a problem, how can I solve that problem, right? Same thing here, right? Just because you hear about the design patterns, all those great things, doesn't necessarily mean that it's the best thing to use. A couple weeks ago, I did a presentation about microservices, and it was actually a pro microservices talk. But one of the things I was talking about was that one of the issues we had was that everyone got on this microservices bandwagon, and then found out that they're great for some things, but some other things are horrible, right? That make your life miserable, right? But people didn't think of that. They didn't think of all the trade-offs. So, and you're also my next point, right? We need to think about the trade-offs, right? So the problematic patterns. It's hard for me to say. So what are these patterns? Well, first off, we're not talking about ANA patterns, all right? So I'm not talking about the patterns that are definitely bad. You want to try to avoid these kind of things, right? These things that definitely cause issues. Now, with that being said, almost all of these, you could probably find a reason to do it in a certain, hopefully limited scenario. Well, copy paste programming, right? Well, if we didn't do copy paste programming, Stack Overflow would have died a long, long time ago, right? And it's, the problem with copy paste programming is usually the whole problem we have with Chat or Copilot right now is people are using what Copilot gives them and don't have to actually look at it and see what was it actually doing, right? So we're not talking about those, but in particular, I'm going to talk about 3 patterns. So you notice I've said the word singleton multiple times. That's one of the patterns we're going to talk about. We're going to talk about the observer pattern, and we're going to talk about the factory pattern. Right. So these are some of your more older patterns, some of your more common patterns. Anyone who took, computer science or information sciences, you definitely learned about those patterns. It's probably one of the first things you learn, right? These are pretty foundationals. So the singleton pattern. I'm trying to remember. Let me take a quick look at something real quick. Okay. I had 2 presentations that are very close to each other. And it's funny, this one is the bad parts about design patterns. I have the essential design patterns. So they're very similar talks. And I had to remember which one one of them I actually have diagrams and the other I have code. So this is the one with code. So what are we talking about with design pattern? So, or singleton pattern. So here, again, I already mentioned, the whole idea you have a single instance, right? And only ever one instance within a running application, right? So the general, hey, what's a good example of using a singleton pattern are like games, right? Your player should only ever have one instance of that player, because otherwise you've got a problem, right? That's the kind of things we're talking about. One of the things that they provide is this global access. And one of the reasons why people like using the singleton pattern is that global access. That anywhere throughout my game, I have the access to that, because it's a reserved memory space. It's there, and it's available. So it is very useful for that. They also generally provide lazy initialization, right? So I don't have to initialize it right away. I can initialize it when I'm actually ready to start using it. Generally, that initialization is a little smart because it notices, oh, you haven't initialized it, so I'm now going to initialize it, right? So I don't have to actually make a specific call to initialize it. I just start using it, initialize. Almost always I'll have a private constructor, because again, not almost always, it's part of the pattern, because you don't want a public constructor. You have to be able to have a controlled way of initializing those objects. And then, again, depending on your language, you'll have a static instance within your method and properties, because you don't want to be able to change them. So what does this look like in code? So I'm used to giving this at conferences where I have to say, if you don't like C#, these are really simple examples, but I hope you like C# because you're here at the .NET conference or that. But here's what we look at like our singleton class, right? So in here, this is a logger, which is another good example of a singleton, right? You don't want multiple loggers running around, right? So we can see it. We can see that the constructor is private, right? Because you shouldn't be able to create that otherwise. And we see we have that get instance, right? And honestly, you could have better names than that, but where notice what it's doing. Is my private instance that I keep, right? Is it around? If not, create it and then return it, right? And we can see a log message, right? So really simple. Oh, and I just realized all those things I just said, I have blown up like that. So, so the next object you'll have is your main object, right? So, here's where, this is what basically ends up using this. So we can see here, we're going to use that logger. So we're going to say, get instance, and then I can start logging my messages in there, right? Whoops. Here we can see that we're going to use it with a service, right? So perform a user action, and so forth. Here is showing just another object, creating it. And again, it's just using the get instance. So it's going to use the same instance, no matter how many objects that I use with it. So, and you could do things like this, to ensure that, you're using the same instance. So, so some good things about this, right? Well, like here, we have a centralized logger, right? Because again, loggers, one, could be expensive, right? If you think about the memory they use and the resources they need. And that's a perfect example where you'd want something centralized. We have global access to that logger. So throughout my application, I can do this. So, think about if you think about like an ASP.NET application, right? In your program.cs file, you set that up. You set up your logger, and you use it throughout. It gets injected, and it's using a singleton pattern doing that. Again, you saw that lazy initialization. I didn't have to initialize. I just start using it. So I didn't have to make sure. Did I already initialize it? The object itself is handling it. We get that reusability of the instance. It was pretty straightforward to use. Right? I just start using it. Right? It's honestly a lot of times. If I am building a singleton, I don't even have like that get instance. I just start writing to it. Right? And that's pretty much the way how Microsoft does their loggers. Right? If you look at them. And then the initialization is pretty simple. So some really good points as to why to use it. But so what are some of the bad things? Well, number one, I now have a global state, right? So the state is global across the whole application. And there can be problems with that. One, that state can start getting big, right? And, because I've got all these different objects using it, they're adding to it. And so it's getting big. It's not necessarily, disposing of that memory as quickly as it could if it was in separate objects. But also, it could be a security issue with that, all right? If your applications do a whole lot of different things, and you've built more of a monolithic application, well, now that because it's a singleton, different parts of the application can actually see data they probably shouldn't be able to see. So that's a concern. By its very definition, is tight coupling. All right, I now have this object going all over the place. Everything is dependent on it. All right, so that's by its very definition. And at least as a distributed application architect, coupling is evil. All right, it definitely provides testing challenges. You can't test singletons directly. All right, you have to mock them. And And mocking works and does great jobs, but your mocking should be because you have no other option, right? And with the singleton, that is the case. They hide dependencies because again, that was somewhere over here. I don't really know it. I just know I need to use it. So I don't know what it's needed. Again, going that logger example, all I know is that I need a logger. I don't know what all that's bringing in, right? And when all of a sudden my performance is getting slow, I don't understand why, because I'm looking at all my code and I'm like, well, this all should be good. Could be like that. The initialization comes inflexible because you don't control the initialization. It can cause. Here's one of the biggest issues: is thread safety. All right, because again, you've got this single thing that's going all across, and the moment you start doing any multi-threading type coding, singletons are really, really bad. They cause a lot of issues. There's ways around that, but you have to really think about that. Race conditions, double check locking, deadlocks are a real big issue. And then, the resource management. And then finally, and honestly, this will come up on almost every pattern I mentioned, not just these, but in any pattern I bring in, is the potential for misuse, right? The idea where everything becomes a singleton because, well, that makes sense, right? One of the hardest parts when dependency injection got added into .NET is, okay, now I need to decide, well, is this a singleton? Is it I can't remember all the models off the top of my head, but transient, scoped, and of course everyone, I don't know, but I understand what singleton means. I'll create a singleton, right? And I've done it, right? And it's like, I can't remember which, I'll just create a singleton. Well, that could be a misuse, right? Because again, I'm probably providing more than what I needed. So, they're not horrible bad things, right? These aren't, going to be, well, they can cause problems, especially that thread safety issues. But, things you have to consider, right? So some alternatives, well, just straight dependency injection. Of course, now, again, depending on the DI model you're using, you have to think about that, you might be using singleton. But, that could be a better way, right? So instead of just creating a singleton object, you inject that into your object. So, because that can definitely be a better way. The factory method, of course, notice that's going to be one of the patterns I'm going to talk about. It also can cause problems, but that's another good one. Some other good ones: the service locator, IOC, prototype patterning. So there are some good ones, right? To use. But even with these, you have to think about them and make sure you think about the right ones. So that's singleton pattern. Any questions about singleton pattern? Cool. All right. So the observer pattern. So anyone who knows me would say, Chad, you're the event-driven. That's your whole life. How could you ever say the observer pattern is bad? Well, one, observer pattern is only part of event-driven architecture, but it does definitely cause issues, right? And event-driven works really well in distributed systems, not necessarily inside the one system. So what are we talking about? Well, so observer pattern gets a little more more complicated, but in reality, it's not that hard, right? So you have a couple key components. You have your subject. So what are we concerned about? What do we want to observe, right? We have the observer. So the thing that, that we're observing, this object is happening. And then, those will be, generally our interfaces. Then you'll have your concrete subject and your concrete observer. So the implementations of that. And as far as your workflow, you'll register. You'll say, hey, I want to know when that thing happens. All right. Slightly different, but when I talk about event-driven architecture, I always say that the idea is that I probably did something, and I bet you someone wants to know about it. Same concept here, right? Something happens, and I probably have something that we need to know. A great example of the observer pattern is like in Windows applications, which like no one writes anymore, but they have the what is it called? It's been a while since I've done it. Basically, it's the object that tells you when something changed on the screen. I'm drawing a blank on the name of it right now, but that's the observer pattern, right? Because it's noticing things happening on the screen. The field changes, and tells you that, right? So you're registering, and then I create an object. I'm registering and say, hey, I want to know that. Then you have the notification, hey, this thing just happened. You may or may not want to know about it. And then finally, you'll have your update. So the thing that we're actually updating to okay. Someone I know who's also supposed to be presenting right now sends me a text message. That's fun. Which is why I checked. I see who it's actually Phil, and I know for a fact he's presenting tonight at another.
I was actually sitting here thinking to myself, I was like, I wonder if it's Phil.
It is Phil. Yeah. And I'm like Phil's keeper. It's.
What's the message? Have you read the message?
I did read the message.
Okay, all right. It
So-
might be emergency or something.
No. That's why I checked. All right. Anyway, then you have your update, right? So this doesn't necessarily happen, right? But generally, if I'm subscribed to an event, I'm waiting for that to happen. I'm going to do something with that. So, all right. So, what does this look like in code? So, honestly, this is going to look a lot of different ways. Goodness gracious. Oh, okay. I won't repeat what he said, but yeah, that's funny. Yeah, there's different ways you could actually implement this pattern. The code here is straight just off the pattern, right? So pretty basic. But here, so we start off with the subject, and we can so again, this is the what we're paying attention to. So you can see we've got a register observer, remove observer, notify observers, right? And then we can have like our progress. But your three methods there, you're pretty much always going to have those in the observer subject. So then you have your observer, the thing that's actually watching for those things. Excuse me. Like I said, you won't actually necessarily have an update method, and it probably will call it something different than just update. But the idea is you have that type of concept, and a name to that. And then here we start seeing implementations of that. So we can see that we're setting the stock price, we're registering, where we're just keeping a list of things that are observed. You can probably start seeing maybe a potential problem. I'm having to keep a list of things that are observing this. Again, I forgot I blew this up. So here you can see we've got the observers, and then adding those in there. Okay. And then you have your concrete observer. So I've got the investor, and then doesn't do a whole lot, but it'll just print out a message, right? Not a very useful application, but and then the implementation, right? So see this one, I didn't blow it up. That's why I was looking at. Oh no, I need to click. No, not this time around. Oh my goodness, Phil. Hold on a second. There we go. Told him I'll take care of that after my presentation. No, I'm not going to call him. All that would be kind of funny. So here again, we're seeing the implementation, right? So we're going to create that stock market. We're going to create some investors. We're going to register those investors, and then we can see that we're setting those stock prices. We're going to remove, set another stock price, right? So nothing all that complicated. So some good things about this. Well, one, loose coupling, right? Because now I'm not actually like reaching out to the thing that's producing events, right? I'm letting it come to me, right? And so that's providing a loose coupling. I don't necessarily know exactly where it is. All I know is I need to observe it.
I
Yes.
mean, you don't need to explicitly reference the things you're trying to get the information.
So that's why actually,
Except for once.
that's why in the bad I start saying that it's actually not exactly loose coupling, because actually I do need to know where it is, right? You know, true loose coupling, I wouldn't necessarily, it's a middle piece, and I don't really know where it's at, right? But here, I mean, obviously I do need it because it's objects in a class, right? So I need to know where it is. But it's somewhat loose coupling, all right? Next one is you're going to get scalability, right? Because if you think about the way how the observer pattern is, I can have all these different objects listening to that, so I'm able to scale out to a whole lot of things. One of the reasons to use the observer pattern is to, hey, I'm going to produce all these different events, and I can have multiple things listening to it, and then react to it, all right? And so so you can get some scalability with that. You can get flexibility, you can get extensibility, right? So the investor example, right? Well, generally, if we think about investment type applications, there's not just one kind of investor, right? You'll have your small investor, you'll have your qualified investor, you'll have your institutional investor. There's all these different type of investors, and I bet you we're going to do different. I know for a fact because I've done some stock market type stuff. You're going to do some different things based upon what type of investor they are, all right? So the nice part about this is I can more easily do that, because I know that this is representing an institutional investor. So when that event happens, I'm going to do something slightly different than what I would do for like a small time investor. I get reusability because again, I can use the same type of code to read multiple types of events, right? So that helps with that. I do get maintainability because now I'm separating the code a little bit, right? So it actually helps with maintainability because you're making code more single focused. And then finally, I mean, it's all about dynamic relationships, right? And so we can create relationships, remove them, as a need be, right? Again, investment thing, I care about that stock today, but I don't care. I got rid of it. I'm a day trader, so I only had it for however long period. Now I'm no longer doing that, so I don't care about it anymore, right? So relationships are dynamic, but there are problems, and one of the big ones, and I actually wrote an example of this, is cascading updates. The whole idea that you get an update that triggers another update, that triggers another update, that triggers another update. And this is not uncommon in the observer pattern, right? Especially inside of an application. So I mean, here's where you're seeing that we have the observer, and again, it's not doing a whole lot in this one, but these can happen. Well, that too. Yeah, I mean, obviously, again, code is very, very simple to just prove the point. Not to show how the absolute best way to write this code. So, some bad things with this. Number one is performance. Okay, when I have just a couple items listening to it, no big deal. All right. What happens when all of a sudden I got a million different things that are listening to this thing inside a small little console app? All right, that app is going to get super slow. All right, and that's where the real problem comes up. And again, that's why I say, when I talk about event driven, I'm talking about distributed, and I'm distributing everything. Here, everything's contained within that, and so you get a lot of performance issues. It's not unusual to have memory leaks because you're holding on to these objects for long periods of time. You keep on waiting for events to come in. They're not getting cleaned up quick enough. Honestly, I know I've had to resolve many memory leaks, with this type of pattern. Next one, order dependency is hard, right? Technically, there's no guarantee, with just the pattern as is. I mean, people have solved this problem, but if you just look at the pattern, I can't guarantee that you get the messages in the same order I intend you to get them. And even if you can say, oh, well, put a sort order on there and make sure you always process it. Well, I can't guarantee that the listeners are actually going to follow that sort order, right? I mean, so there's a lot of problems with that. And so if ordering is important, I will generally tell you, again, inside an application, you don't want to look at this. It's going to cause you more problems than worth. Again, that unintended cascading events, where I do one thing and all of a sudden it does all these other things that I didn't necessarily mean to do. There are security concerns because, again, in the idea is anyone in your application can do this, and if you're working on a big application, big monolith application, and again, same thing we were talking about signaling, where all these objects can see the same things. So I said one of the advantages is and where I mentioned this, but about the loose coupling, that by definition this is loose coupling, but in reality I have tight coupling. And what I mean by this, and I always saying this, but I now have the idea that I need to know where that is. I need to know what class it is and what where in my application that is, right? So at that point, I now have I have tight coupling. I can't just go rename it. I mean, yes, now we have tools that I will globally replace your code usually, but in general, you can't just make changes to it and expect everything to just work, right? And that's the kind of things we're talking about here. And then finally, and this is true, especially in event-driven architecture too, it's hard to debug these things. When these things start going wrong, when they start going wrong, they go wrong. It's usually not the simple things that happen with these kind of things. And now you got messages going all over the place, and you're trying to figure out what's going on. Why did that message get sent, but not this message? Who all is receiving those messages that's all of a sudden doing things? It's really hard to track it down, right? And you end up doing a lot of debug statements, print here I am, right? Those kind of things. And I'm not ashamed to say I do that all the time. Still do that, especially if I'm doing any JavaScript coding. Oh my goodness. Alert is my friend.
Have you used the observer pattern with multiple levels of hierarchy, where one level is notifying this level, and then this level might be cascading out to third?
The design pattern, I can't think of where I have. Now, if I take it, extend it out to event-driven architecture, all the time. But again, in that model, I talked about, that's where you really are getting loose coupling, because that's happening, but the original sender didn't know that, right? And it doesn't care that it happened, right?
Just communicates with the next in the chain and doesn't worry about it. I guess you could have a circular situation around too.
Yep. Oh, definitely.
Have you had that happen?
Well, I'm sure I have. I don't remember a situation, but there's no way I haven't had that happen. So some alternatives. You got the event aggregator. So basically, instead of observers, you basically have event aggregators. So they're aggregating the events, and then you go to those, right? So instead of getting the messages, instead of the message being pushed, you're pulling the messages. Basically, the way to think of that. Queue could be an example. But yeah. Reactive extensions, I really don't know much about reactive extensions. It's a whole library. It's actually a little bit more than just a pattern. But I know that you see that more in the Java world. We don't see this too much in the .NET world. The mediator pattern, which is becoming more and more popular in the .NET world. Honestly, the mediator pattern is probably better than the observer pattern for most cases that you're trying to do. And sure enough, if you're going to use the mediator pattern, I've drawn a blank name of the mediator, but it's spelled strangely. Same guy who wrote Automapper wrote that one. You can do a callback delegate. Now, grant you, this is a really old approach. We don't see this as much in modern applications, but it still works well, right? And especially in a tightly coupled system. And I don't mean tightly coupled in the bad way. Right, but where everything's all close and together, these can actually work really well. Message queue patterns, state patterns, your command pattern, but probably the one to look, is that mediator pattern I was talking about, and then the message queue pattern, right? Which basically get it somewhere where I can then get a queue and I can control that a little bit better. Is really the big things there. So that's the observer pattern. So last main one I got here is the factory pattern, right? So factory pattern is really interesting. What I've noticed, and of course, I've been doing this for a long time, and the factory pattern is one of those patterns that it gets really big. All of a sudden, someone uses it in a novel way, and it becomes the big thing, and then it goes away, and and everyone forgets about it, right? It's one of those kind of patterns, but it's a really interesting pattern. So in here, first off, you have your factory interface or your abstract class, and really can use either way. So either just an interface or an abstract class. I will tell you, I generally do abstract classes. Generally, I almost always prefer an abstract class over an interface, because to me, an interface is just it's just more code to be out there. Whereas at least the abstract class, I'm starting to do some work with that interface. So you've got that. You have your concrete factory, so the things are implementing the interface or abstraction. And then you have your product interface or your abstract class, and then the concrete products. And then finally, you have your client, so the thing that is actually using this, right? So the whole idea here, I'm trying to remember. Okay, yeah, the whole idea here, and again, I have this in my other talk, and in there I have a really nice diagram, but this is the idea that I need to be able to create some type of object. So, think of like, you're building a system. So Jasper engines, we build engines. I want to represent an object that represents an engine, a gas engine, as opposed to a diesel engine, or or a transmission, or a transfer case, or all the other different things we built, right? And I can literally go out there and to a factory method and say, hey, give me a gas engine, right? So the object that represents a gas engine has the methods and the properties that gas engine has. Or give me a diesel engine, and it does that, right? So that's kind of what we're talking about here. So in code, and I just remembered, I think my code, no, it's not. So here we see that product interface. So again, very simple in this one, but it'll be your objects that represent them. Maybe also methods in there. Just depends on what you need here. Here you can see that I've got I got the iProduct, which has a method of display, and then I've got two different very simplistic implementations of that, right? And again, I blew it out, but okay. Next one is your factory, right? So this is what's going to create those products for you, right? And more importantly, so this is what knows how that happens, right? So the big advantage here is the consumers of these don't need to know how it happens, right? Only he knows I need a gas engine or a diesel engine or what have you, right? So here you can see, I've got my interface, create product, and then my implementation where I just create a project. And just in this example, just returns a product day. Honestly, you're wasting your time if you're doing that in a factory pattern, right? Really, where a factory pattern comes up is I'm setting objects the right way, and maybe getting the right values, because maybe instead of just say an engine, I'm saying give me a Ford F-150 engine. That's not the right names for it, but y'all get my point, right? That has those properties. That's a 8-cylinder engine. It's got these kind of values in there. It's got these properties in there, and that's such. And then here we have our client, right? So, create a new factory, and then, go ahead and, create my products. I just noticed, I've never noticed this here before. I create the factory A. I really should be factory A, factory B, but anyway. So, really easy pattern to understand, and there's some really good things for it, right? Number one, like I said, I'm extracting away and I'm encapsulating the code it takes to build these type of objects, especially when I have things where there's slight differences, right?
Comment on the Meetup board, the audio aspect apparently is not working.
Well, that's awesome.
Sorry, I'm looking forward to that.
Well, what's interesting, some people must be getting it.
Oh, okay. Maybe it's just that user.
Twitch, it's working.
Okay. Maybe it was just for a few minutes or something.
Yeah. I mean, wouldn't surprise me, but oh well. So yeah, so again, the whole thought, where I can make it easier, I can encapsulate that code so I don't have to repeat it a bunch of times, especially when you have those slight variations, right? Where you're passing the parameters and saying, give me a V8, give me a V12, whatever, right? I don't know why I said V12. That'd be, I mean, they are V12s, but not the Jasper's making. We'll custom make them for you. Next is the idea of this whole idea of flexibility and extensibility. Because again, in my client, I don't need to be concerned of how it happens. I just need to know it happens, right? That's where it's really important. It just happens, right? I get that centralized control because again, especially if it's hard to create that object, there's a lot of things, a lot of logic goes in here. The awesome part about the factory pattern is I have a central place where it's happening. So I know that I can go to one place in my code base to find, when I need to fix code, I fix it in one place, right? And so there's some really nice parts about that. Code maintenance, I was just talking about that. Code readability, right? Because again, in the client code, it's just create, right? Because again, I don't necessarily care how it gets created. I just care that it happens, all right? A great example of the factory pattern. So this is before Entity Framework. And again, you all know I'm old. Some of you all probably don't even remember before Entity Framework. I know that because I have people who there was a time before Entity Framework. I'm like, yes, there was. But right before that, they had the data factory pattern or data factories. And the idea was it was creating my database connections, and it was doing all that work to figure all that out. And I literally could just say, database.create, and it would create the object for that database. And it made the code so much easier to read because I just had to pass a couple of values. Here's the name of the database. Here's the table I want, or whatever. All right. The nice thing is you're inverting the dependency, right? So you get that separation of concerns because again, as the client, I don't care, right? All I care is that it happens, right? So I'm separating it, and then I'm getting consistency because I've got these factory patterns out there. I can assure that throughout my application or applications, right? Because a lot of times these get used in distributed class libraries. I can ensure that it'll always happen the same way. All right, so there are some really good things, and admittedly, I really like the factory pattern. It really does serve its purpose well, but there are some bad things. Number one, there's overhead with it. The factory, those factories generally are pretty heavy because they're doing a lot of work, and so you do get some overhead with these. So you have to be concerned about that, and you have to watch out for that. Next one is, one of the hard parts about any time you extract code, and the whole idea of factory pattern is to extract code away, is that you get this whole excessive extraction where, okay, I have an error here. Well, now I need to go over here. Oh, that gets me over here. Now I got to go over here. All right. Yeah, I'm having to go all these different places just to find why this error happened in this one line of code. And it turns out it's 5 or 6 levels deep. And that happens a lot with the factory pattern. So you have to be careful with that. It is definitely tight coupling, right? Because I'm declaring a factory that, hey, here's where I'm going. Again, it doesn't necessarily mean it's the evil, right? It just means you have to be careful of that. Factory proliferation. I'm very guilty of this. So again, I talked about the database factory. I remember it well, and that's how I learned about the factory pattern. So for those who don't know, I'm not formally educated. I learn all this on my own, and so I see this pattern. I'm like, oh, this is cool, right? And I start researching it. I'm like, this is awesome, and I start using the factory pattern everywhere. It was in everything I wrote. I was definitely abusing it, and it happens, right? Again, we're technologists. We love things, and all of a sudden we start seeing them, and we continue to use them over and over and over. They have a tendency to create these complex hierarchies. It's not unusual to see a factory pattern has a factory pattern has a factory pattern, right? Because, and again, it kind of goes in with the excessive abstraction. The same thing here, right?
What do you mean, like a factory for factories?
Happens all the time. So I'll use my engine example, right?
Okay.
So I talked about, hey, an example where, because I need to be able to create, a gas engine, a diesel engine, all these different types of engines, right? Well, I bet you in there's still commonality, even though there's differences. So I bet you in there these are all common, so I'll put those into a factory, right? Oh, these are also common. So it does happen quite a bit.
But you have a factory where you say, I'm gonna need a factory which can make these, and so I want you to generate that factory for me.
Yep.
Okay.
Yeah.
Surprising.
So, okay, yeah. So next big issue you need to watch out for is now, I'm having to configure those factories inside my code, right? And I'm having to keep that memory in there. Honestly, this has gotten better, because now we have better systems that handle this kind of stuff. But it's still, it's a trade-off, something we need to think about. It is a violation of the open-close principle, right? So the open-close principle, the idea that it's let me remember this again, open for extension, but closed for modification, right? Well, but it's actually the opposite, right? If you really think about this, so, you have to watch out for that. Again, it doesn't mean that it's bad, right? It just means you have to be careful for it. And then finally, there's a learning curve to them. Generally not at first. I mean, the factory pattern itself, to use it is easy, right? To implement it is not, right? Because again, you need to think about all these kind of things you're thinking here. So there is a bit of a learning curve. We have to think about that, how we use this. So some alternatives, number one is just directly instantiated, right? Again, I mentioned, in my example, that was an extremely simple thing. And I will tell you, if I ever code review a piece of code, that's all it did in a factory pattern, I would probably get up and slap you, right? Not really, because I'm joking, right? I don't need HR after me. But point being is, that wouldn't make sense, right? There are times when you just directly initialize the object, right? It's easy. Another thing is the builder pattern. So the builder pattern is slightly different, right? Because in the builder pattern is all about the going step by step, right? And so that's definitely a pattern to look at. The abstract factory pattern, where it's kind of abstracting more of this. It's a little bit more practically useful, right, to use. Some other ones here, your static factory method. Those are a bunch of things. Your server's locator pattern. So the idea that I'm not necessarily calling a method within there. Instead I'm it's calling another service outside there, and I'm locating where that service is. Dependency injection again. The strategy pattern. Strategy pattern is really cool. The idea that hey, like one example I use the strategy pattern is like media translation, right? There's probably some commonalities, right? Converting between from one thing to like an MP3 to an AVI file. No one even knows these file types anymore. Again, I'm old. The other old guys in here are like, yeah, what are you talking about? I know exactly what you're talking about. I remember the days. Oh crap! I don't have the codec for the AVI file for that for that type of AVI file, right? Anyway, strategy pattern. That the whole idea is okay. It's here I'm doing this, right? So use this strategy to implement that, right? So some really nice ones to look at that.
Can I ask you a question about the strategy?
Yeah.
How do you signify to it? I haven't used that. How do you signify to it? I don't think I have. Maybe I have. But how would you signify to it? I've got this type of thing, and then it decides how to act upon that. Is it just a file type example? Are you handing it the file, or are you giving it a file name, and it's looking at the extension?
I'll give the typical consultant answer. It depends, right? There's a lot of options. Actually, I'll tell you what, right after the presentation, I'll pull up, I got some slides that probably help you understand that real quick. I'm pretty sure I know they're in GitHub, but I'm pretty sure they're on my machine right now. All right. So, we talked about 3 patterns. I purposely picked one pattern in each of the categories from the Gang of 4 book, right? So I didn't necessarily pick actual bad patterns. Honestly, I could have done this nitpicking on every pattern you could ever think of, right? And that's really the important part I want to talk about, the importance of context, right? Making sure we understand what we're doing. Some things we have to understand. Is the pattern the right thing for the problem we need to solve? Is it because you read about it, and you said, that is really cool, I want to do it. Chad said the strategy pattern is cool, so let me go use it in everything I build now, right? And, but was that really the right solution for that? What are your actual project requirements, right? What do you actually need to do, right? Do you actually need to observe that things are happening, right? Is that the right thing to do, or do you just need to be able to react to a simple way? What does your team understand, right? This is, one of the hardest things I see, especially when people learn about new patterns, is, you get this idea of, oh, okay, well, let's bring this in, but then no one understands how that works, right? Which is usually when you don't understand the trade-offs of them, because no one understands how they work. So make sure you understand that. What is your technology stack, right? While these patterns are not meant to be, language specific, certain languages excel better at certain patterns, all right? Now, sure enough, again, I can make the general assumption everyone here is doing C#. C# is a generalist language. Basically, any pattern, you could throw almost any pattern in it, and it's going to work just fine, right? But as opposed to using Python is still more general than some others. But some of these patterns, I don't remember off the top of my head what you couldn't use, but you wouldn't necessarily want to use them in that scenario. You need to think about how your system evolves, right? And you want to make sure you don't get yourself caught up in a problem because you made a decision. What are your performance considerations? So like I said, the observer pattern is awesome, but it can definitely cause you performance issues because all of a sudden all these things are reacting to events, and if there's firing off a lot of events, that could cause issues, right? So those are the things you want to think about. And then finally, like I said, what are the trade-offs? What are the constraints, right? You really need to think about all these type of thoughts. And I love on the last one I saw, I was at Code Mash, I was attending this talk, and I forgot the exact quote this guy was showing, but basically, paraphrasing it was, developers understand how things work. The architects understand, what the trade-offs are, how it doesn't work, right? And that's the whole thing, right? It's, getting that point that we can understand all that. So that's, it's a short and sweet presentation, but, again, the idea that, patterns aren't always the best thing in the world, right? But, just truly understanding, what they're useful for and what they're not useful for. So you don't have to. All right, let's see. Let's see if I'm pretty sure I have the other talk in here. Central. I actually don't, but let's just do this real quick.
Is this the strategy pattern?
Yeah. So
Is that a stock photo, or do you think that?
what's,
Probably Windows back.
oh, yeah, that would. Well, it's fine. I just realized I'm downloading the PDF version, but that's fine. So see, like here's my essential design pattern. So talk about the factory pattern. Oh, wow. I just noticed these slides got some font issues.
Were you looking at like object classes, or how are you making the determination?
Termination of what?
What actions to take, like what strategy to apply? I'm guessing that you had some.
Well, again, it really is going to depend on what is you're trying to do. Let me go here and just grab the actual slides.
I have done stuff where is this a subclass of a certain class? And if it is, then handle it this way. And that.
All right, now I can search for these a lot easier. So sure enough, yeah. I mean, like here you can see the graphical view, right? So, as the pattern's written, right, you have your context of the thing that needs something to be done, right? It calls into your strategy interface. And the strategy interface basically, again, just by the pattern, knows that, I need to call strategy A, strategy B, or C. By the definition of the pattern, it's so simple, right? Because then it's up to you to how you implement that. So in this code example, okay, yeah, I was trying to remember which one I got here. So I'm doing like discounts, right? So you can see I'm creating an interface of a discount strategy, with a simple one method of applied discount. And in here, so I've got my different strategies, right? So I've got my no discount, my seasonal discount, my loyalty discount, right? And then, it's just doing decimals, basically a 10% or 15% discount. So in the context, it'll say, set my discount strategy, based upon, what I'm doing. Here's where we actually implement this, because here's the important part, right? So, we can see that, we're creating a new calculator, and we're saying, no discount, right? So I calculate the price, right? So I'm actually feeding in here, I'm actually saying use this interface in this example, right, of how to do that. So like in the file translation, I'm saying, hey, I've got a MP3, so I'm going to say, I'm going to create an instance of that discount strategy, using MP3 objects instead.
Are you recognizing the MP3 object because you recognize the class?
I mean, in that example, I'm probably looking at the file name. I mean, that's the most likely thing you're doing. Again, it really does depend on what you're doing. So like some examples of where I've used strategy pattern is, similar to like this idea where, I know because like of a property on the class that I need to, I need to apply this type of strategy because we're going to do this thing to it, right? So just generally how I would end up using it.
Okay.
Yeah. Well, cool. Well, I mean, like I said, that's what I've got. Next month, I don't have a schedule, but we'll try to. My intent is I'm going to be at the MVP Summit next week. I'm going to try to recruit someone to speak for us for next month at the summit. But then in May, like I said, we'll have a talk about Microsoft agents, and like I say, there's a lot coming out in the next couple weeks. So there's some big announcements coming out, and then in June will be a talk on security. So, and with that, I and some other folks will be going over to Brick House. Yeah, I actually remembered the right name this time. She just sings that old song. I forgot who was it. Commodores.
No, it's Rick
Or Rick James. Yeah. I'm not so sure that's politically correct song to use.
Right?
Yeah.
He was singing about food.
Yeah. So I hope you join me there. If not, I hope you come next month. So, thanks.
Thank you.